Hello, I'm Tallyn from Design Informatics, and I'm going to talk about location-aware smart contracts and the GeoPact system we've built to engage publics in these abstract concepts. Location-aware smart contracts have arisen as a result of a combination of some relatively recent technologies, so IoT, such as Bluetooth beacons, that can help give us more confidence about location data that's captured, and distributed ledger technologies, or DLTs, such as blockchain, that can potentially help give more confidence about data that's recorded. So distributed ledger technologies are where there's multiple copies of the ledger distributed over a vast network of computers, and because of this, they are difficult to hack or change. Smart contracts are programmatic agreements that run on distributed ledger technologies. They're computational code, and because they're running on these ledgers, they're also difficult to hack or change, and so we consider them contracts. They contain conditions that need to be met, and when these are met, they will execute and perform certain actions. When we talk about location-aware smart contracts, these conditions are to do with location data. So location can mean a number of different things. So we could talk about a thing or a person being in a specific place, or two things being next to each other, or anything being near to a specific object. So what can we do with this? Well, if we're going to the trouble of writing a smart contract and running it on the blockchain, we're probably looking for something to happen that's fairly high value or important. So this could be unlocking a door or transferring money. And it's better if these things can be triggered directly by the smart contract. We're interested in opening up these ideas for exploration, and in particular, we've been thinking about transport and delivery, because this is a sector in need of some fairly radical innovation, and smart contracts could potentially open up the design and development of new systems and services to many more people, because they could be potentially fairly easy to construct and cheap to run. So we've developed the GeoPact system and a series of lockboxes that will enable people to start thinking through these ideas, and we have shown them at 3 exhibitions. So I'm going to talk about the GeoPact system and the lockboxes now. This is the system. It looks fairly complex, but I'm going to break it down. So in the world, we have IoT beacons and the lockboxes. We also have a dashboard that displays the current smart contracts that are running, and we have participants that are taking part. The Geo server mediates between the world and the blockchain, and it does location matching. On the blockchain, this is where the smart contracts run, and this is where we store all the data. So this is the lockbox, and this is really pivotal to interactions with GeoPact. So it's basically just an empty container that's either locked or unlocked, and this lock is controlled by smart contracts. We also have a display screen which shows instructions coming from the smart contract, and this says what to do in order to get the contract to execute. So here we have the GeoPact assembly laid out at the Tate Exchange. We've got an IoT beacon on the left, we've got lockboxes on the right, and we've got our dashboard in the center. We made a number of smart contracts for these exhibitions. So this is the Courier contract that people could come and participate in. So here a participant role plays a courier, and they need to collect a series of items to complete the contract. They take a lockbox and they start at beacon A. They're instructed to head for beacon B, where they'll meet a person who has an item for them to collect. This person is role played by a researcher. From here, they're instructed to go to beacon C. and collect an item from another lockbox. And then finally, they go to beacon D, where they collect an item from a researcher who also has a lockbox. At each beacon, they make the collection in a different way, and these are the items they collect. These go together and can be built into a little electric Lego car. This is the dashboard, and it shows the courier contract running on the left. The current active step is that box 1 should go to beacon C. So that's what the contract is looking to happen. In the central panes, we show the status of the boxes. So here we've got a message which says go and collect the tyres from C. And that's the message showing on the box. When the participant arrives at C, the box will unlock, and you can see that that step is now active. Here, the participant can then collect an item from the researcher and place it into the box. They close the box, and then they're instructed to press a verify button to say that they have performed this action, and then the box will relock. All of this activity is captured on the blockchain, and this is shown in the pane on the right. So here we have a participant at the Tate Exchange. She's at beacon C, and she's collecting an item from a researcher. These were really good opportunities for participants to be able to ask questions of the researchers and also share their thoughts with them. So they were really good points of discussion while they were going through the process. Here we have a participant at Warwick, and he's about to make a collection at beacon D from another lockbox. And this was a good opportunity for participants to actually just try a transaction by themselves and see what that feels like. He also has an electric scooter, and these lockboxes were designed to go on the front of scooters so that people could get from beacon to beacon. We've got some people looking at the dashboard here, and this was a really good way to spectate on the participants actually walking through the contract, whilst at the same time watching the steps of the contract execute as the participant goes through it. We had lots of conversations with people as part of these exhibitions, and we talked about the types of situations that might benefit in particular from the use of smart contracts. We also talked about how the real world is messy and what happens when things don't go as planned and how the contracts may adapt. And we would often come back to the first point here, was that some situations might benefit more from smart contracts than others. People asked where the contracts come from. Obviously, we wrote these contracts, so they were interested to know how they could write them and how they would do it, and who else might be able to write them, and ultimately who has control of this process. So in reflection, we found that moving from these abstract concepts into grounded physical experiences really helped to demystify these abstract concepts for people. And we had a sense that it really helped to build their confidence that they could understand the types of experiences that smart contracts might enable. Going through a scenario step by step really helped participants to look closely at the details of the interactions and think about the real world consequences. So what happens if the battery runs out, or I don't feel like following this particular instruction right now? Providing the spectation through the dashboard was really helpful, because it meant that participants could understand the whole experience in a different way. So they had the infrastructural overview and the physical experience of walking through the contract. And this really helped to build their understanding. That's the end of my talk. I'm Ella Tallyn. My co-authors were Joe Revans, Dr. Evan Morgan, and Dr. Dave Murray-Rust. And these are our funders there on the left. Thank you so much for listening.